Welcome everyone to today's Explainer. I am absolutely pumped to guide you through this material because today we're tackling one of the most critical transformations in all of observability. We're going to take a calm, step-by-step look at how to take your monitoring strategy from completely passive to powerfully active. Specifically, we'll be exploring how to master this transition using a local Grafana OSS instance, which, you can easily spin up right on macOS. Let's get started. Okay, let's dive into this. It's a relatable nightmare scenario for, well, almost anyone in site reliability or DevOps. You spent literally weeks building these beautiful, comprehensive dashboards. They're totally loaded with metrics, logs, traces, the whole 9 yards. But here's the problem. You still only find out about massive system failures when angry users start messaging your support team. So, why does that happen? Well, it happens because of what we call the dashboard trap. Think about it. Reactive dashboards require constant human observation. If you aren't actively staring at the screen, failures just happen in total silence. The source material highlights a massive, fundamental shift in the Grafana ecosystem: proactive alerts. This decoupled alerting engine basically acts like a centralized brain for telemetry evaluation. It monitors your critical systems autonomously and instantly notifies you, even when your user interfaces are completely inactive. To solve this today, we're going to follow a quick 4-step roadmap. First up, unified alerting architecture. Second, creating an alert rule. Third, contact points and routing. And finally, we'll see the alert in action. All right, let's kick things off with Section 1, Unified Alerting Architecture. The architecture is structured precisely around a 3-stage pipeline. Stage 1 is evaluation. This is where the Grafana scheduler regularly fires off queries against your data sources. Stage 2 is routing, where notification policies step in to evaluate the metadata attached to the alert. And Stage 3 is delivery, where contact points actually send the message out to your team. The real beauty of this setup is how it operates completely independently of your visualization panels. Now, to truly master this system, you absolutely have to understand a core concept: labels. Labels are just simple key-value pairs, things like team equals backend or severity equals critical. As the sources emphasize, these labels are the vital glue of the entire alerting engine. They are the metadata that will eventually connect the alert rules you create directly to their final notification destinations. Moving right along to Section 2, creating an alert rule. Now we shift from the theory side over to practical action. Now, what's really interesting about this is how creating an alert rule is essentially just an exercise in data transformation, and it happens in 3 distinct steps. First, query construction, for instance, writing some log-QL to pull logs from Loki. Second, we use a reduction expression. Since most alerting engines need a simple scalar numeric value, we reduce that complex time series data down to a single number, like an average or a last value. And finally, we set the threshold condition, which simply defines our exact failure boundary. Let's look at a specific threshold. We are setting our condition boundary right at 5%. So for our practical scenario today, we are writing a log-QL query against our Loki logs, we're reducing it to find our overall error rate, and we're telling Grafana to trigger this rule if that error rate ever exceeds exactly 5%. But wait, we don't just want an alert that fires the absolute second a metric twitches, right? That's exactly how you end up waking your team at 3 a.m. for a harmless temporary CPU bump. Checking every 10 seconds, well, actually doing that just absolutely overwhelms the data source anyway. Instead, the sources highly recommend a 1-minute evaluation interval combined with a 5-minute for duration, which is also known as a pending period. This gives you an optimal balance, ensuring the error is a sustained, real problem before we actually go ahead and sound the alarm. Okay, moving into Section 3, contact points and routing. A really defining feature of unified alerting is the complete decoupling of the alerts themselves from their final destinations. You've got quite a few options here for contact point integrations. You can route things directly to PagerDuty, fire off a classic email, or even send advanced payloads to a ServiceNow REST API. But for our scenario today, we're going to focus our attention right at the top of the list, setting up a straightforward Slack webhook for our specific incident response chat ops. So, how does Grafana actually know to send our specific Loki error alert over to Slack? It's all done through notification policies, which basically act as a routing tree. Notice the routing logic in play. It relies entirely on those label matchers we talked about earlier. If the alert has a label of team equals backend, boom, it goes to the Slack webhook in the incidents channel. If it has a label of severity equals critical, it gets routed to PagerDuty. It's just a beautifully organized, logical system.
All right, now for the payoff. Section 4, the alert in action. Let's simulate the exact state transitions that happen in the engine as our Loki error rate officially breaches that 5% threshold we set up.
And this brilliantly illustrates the strict, finite state machine that Grafana follows to provide stability. Right now, the condition is not met. The error rate is safely below 5%, the system is in the normal state, and absolutely no action is being taken. We are all good. But suddenly, our query evaluation shows the error rate has spiked to 7%. The threshold condition is officially breached. But notice the state here, it's pending. This is that crucial 5-minute for duration we configured earlier kicking in. This temporal buffer is active, basically protecting the engineer from those annoying flapping alerts, while we wait to see if this error rate sustains itself or if it's just a temporary little blip. Okay, 5 minutes have passed, and the error rate is still above 5%. The temporal buffer expires. The state immediately transitions to firing. This is the exact moment the initial notification is successfully dispatched to our routing tree, matched by our labels, and sent straight out to our contact point. And here is the final result arriving right in our Slack @incidents channel. Through the power of Go templates, Grafana injects dynamic content directly into the Slack message. Our team instantly sees the exact summary, the severity level, and the specific cluster affected. They are informed proactively well before the users even have a chance to pull up a support ticket and complain. I want to leave you with this final, truly vital thought taken directly from the source material. Look, the goal isn't just to make noise. The ultimate metric of success isn't how many alerts you fire. It's how effectively they guide your human responders to a resolution without completely burning them out. By moving from reactive dashboards to proactive, label-driven unified alerting, you preserve your team's capacity for deep, uninterrupted engineering work. I highly encourage you to evaluate your own observability infrastructure with exactly this in mind. Thanks so much for joining me in this explainer.